Hi, welcome back to the breadboard. In the past couple of videos we were looking at the latest Windows 10 for IoT that was released to coincide with the Raspberry Pi 4th birthday and the release of the Raspberry Pi 3, the first 64-bit version of a Raspberry Pi that included Wi-Fi, Bluetooth, as well as of course the 64-bit core processor. So there were a few differences in there, and the videos that I had done previously to this one showed that the images for Windows 10 IoT, both through Noobs and through direct loading through an ISO image, work perfectly well on a Raspberry Pi 2. But up to now I have not had a Raspberry 3 available to me to try out the images to see if they work fine on there. And a lot of people have been complaining or doubting that the LCD display was working properly. Now I don't have the very latest version of the LCD display, which is the 1.1, but I do have the official Raspberry Pi 7-inch LCD version 1.0. So what I'm going to do right now, I've got a Raspberry Pi 3 arrived today from RS Components. They kindly sent me one so that I could do this for you guys. And what I'm going to do is put the Raspberry Pi 3 directly onto the LCD display, make a new image using Noobs to set up Windows 10 for IoT on an SD card, boot up the Raspberry Pi 3, see how long it takes, but also I'm going to do this directly on the LCD display to verify that it works properly and show to you guys, hopefully, how easy it is to get this all up and running. So without further ado, let's get going. Okay, so first things first, what I have that was sent to me is the Raspberry Pi 3 Model B from RS Components, part number 8968660. That's your basic Raspberry Pi Model B. No Noobs or SD card included. I've got plenty of SD cards anyway. I also had sent to me the official Raspberry Pi black-gray case, which is designed for the Raspberry Pi 3, and I'll show you the particulars about why that is the case in a moment. And also the official Raspberry Pi power adapter, and we'll have a look at that to see if it's uprated or not compared to the earlier ones for the Raspberry Pi 3, which is recommending a 2.5 amp power supply. So let's open these up and see what things there are that are special to them. Okay, this is the Raspberry Pi 3. So aside from the initial standard pieces of paper in the box, we have the Raspberry Pi 3 in its anti-static bag. And there we have that. So as you've probably seen in other videos already, everything is pretty much identical on the Raspberry Pi 3. Let me zoom in a little bit on that for you. So what the biggest thing that's changed is we've got the introduction of a ceramic antenna here for the Wi-Fi and Bluetooth, and the indicators have been moved down the bottom here. So any cases that you may have had before where the indicators were up here and they had exposures for the indicators to be seen from the outside will no longer show the indicator LEDs. Everything else is physically in exactly the same place, so you shouldn't really notice any difference from that perspective. And then on the back of the Pi, the major thing that's different here is the addition of the Bluetooth Wi-Fi chip here. Now this is silicon on board. I don't know if you can see there very well, but it's you can see there's actually no plastic or ceramic covering on that chip. You can see how shiny it is. That's because it's the direct silicon mounted onto the PCB. So with these, you really do need to be careful how you handle them, because the chips are, in some cases, they're so small you could knock them off the board, or you could damage them with ESD. So handle them carefully, and where you can, if you can put them into a case, then do so. So I'm going to be putting it into the official Raspberry Pi 2 case for now. Well, and afterwards I want to be able to mount the 7-inch LCD with this as well, so you can't have the case with it. Anyway, that's the board. Let's go look at the power supply. So this is the power supply. It's RS part number 9098126. And this is the official Raspberry Pi one, I'm told. I've never opened this up yet, so let's just pull this out and have a look. So you've got adapters for pretty much every country in the world, and the ones I want is the 2-pin for North America. Because if you haven't guessed, or you haven't been following my channel up to now, I'm based in Canada. So let's just zoom out a little bit. Okay, so this is the power adapter, and comes with the UK one already plugged in, so we'll get rid of that. Anyway, looking at the back of this, this is indeed rated at 5.1 volt at 2.5 amps. Now the reason they probably put it to 5.1 volts rather than 5 volts is because you will always get a little bit of loss along the length of the cable, and so they're compensating with that a little bit right ahead of time. Some of the people have been using 5.25 volt adapters, but at low currents you're really getting a little bit dangerously close to the high end of some TTL and things, and even if it's not the Pi itself that may get damaged, you do risk something else that you might plug into it that might be very 5 volt, traditional 5 volt plus or minus 5% tolerant, and it could damage those. So it's good that they've only made it 5.1 volts, but it is the full recommended 2.5 amps capacity for the Pi. So there you go, that's all clipped up now, ready to go for my Raspberry Pi 3, and it looks like it's got about a 5-foot cable on it, which is nice because you can plug it in and have plenty of distance to get to the Pi on your bench. Now we've got the case to have a look at. Now the case is RS part number 9098138, made in the UK, Pi case black and grey, and again, got the Pi logo on the top. Now this is it's not 3D printed, it's injection molded and everything. But the thing about this one is it is fully disassemblable. And the other part, the main thing that comes to notice right away, if I put the Pi next to this, is that this is the new location for the indicator LEDs. And you'll see that there are two little clear plastic inserts here for the indicators. They would have used to have been over this side, now they're over here. So this has specifically been designed for the Pi 3, and it actually comes apart, so you can get at GPIO headers, side pieces pull off, so it's pretty easy to disassemble this. I say that, not too easy, it clicks in quite securely, and then the lid finally pulls off like that. So we'll have a look at that later for putting it in here. For now I want to power it up immediately by using the LCD display, so that's what we're going to do. Now the LCD display that I have here right now is currently plugged into a Raspberry Pi 2 with Windows 10 for IoT, the latest version, and it's been tested. Even the touchscreen and everything all works out of the box now for this. So I'm just going to take the Pi 2 off of the back of this, and I'm going to put in the Pi 3. I'm going to obviously leave off the Bluetooth adapter, leave off the Wi-Fi adapter, and I'll only plug in the keyboard adapter, because everything else I should theoretically, if it works correctly, be able to do with either the touchscreen or just the keyboard, because I know that there isn't a virtual keyboard on this at the moment. Microsoft are working on it, but it's not there yet. So let's just get this disassembled and pull the Pi 2 off, and we'll put the Pi 3 on. I'm also going to create a new sorry, not new, but fresh image of the SD card, so that we do it from brand new power up, not one that's already been running with the Pi 2. So let me just get that ready, and I'll come back as soon as I'm ready to power it on for the first time. So in preparing the SD card for this, I'm going to be using the Samsung Pro, which is the fastest SD card I have. You have to remember to properly format the SD card before you put your images on it, and when you're doing the formatting you need to use the SD formatter, which is currently version 4.0 if you're doing it with Windows, and remember to set the format size adjustment to on, because if you've been using this card before, the current partition, as you can see here, only shows up as about 1 gig instead of 16 gigs or 32 or 8 depending on the card size you have. So you just say format, say yes, confirm it, and away you go. That's done. Now I'm back up to the full 32 gig card, and basically that's done for that. Now here is a Noobs that I downloaded. Now because I'm going to put Windows 10 for IoT on here, there's no point in downloading Noobs with Raspbian included, so I took the much smaller images, which is the Noobs Lite, currently version 1.8 zip file. I've opened the zip file, and I'm just going to literally copy it onto the SD card, which is this one that's labeled recovery here, and as you can see right now it is empty. So I just grab everything that's in the zip file and drag and drop it straight onto that folder, and we'll just watch Windows drag it all across. And that's pretty much it. I do have a separate video for creating the SD cards, and I will put a link in the description for it, but I'm not going to go into any more details on what I have just done there. So that SD card is now ready to boot up on the new Raspberry Pi 3. So let's get back across. Currently, obviously, nothing is showing up in my devices because I have no other Raspberry Pis currently plugged into my network. I'm just going to pull the SD card out of my writer, plug it into the Raspberry Pi 3, and we will power it up as soon as I've shown you the newly assembled LCD with the Pi 3 on the back of it. Okay, so here is the assembled Raspberry Pi 3 on the back of my LCD panel. Just zoom out a little bit so you can see better. So just to make sure I'm not cheating, you can see that written in there, Raspberry Pi 3, and it's Raspberry Pi 2015 copyright. So as you can see, plugged in the LCD display, wired everything up exactly as it was before, and all I need to do now is put the SD card into the bottom of the Pi, which is just under here. So we'll just plug that in. So one thing I've just noticed plugging in the SD card is it's no longer the push to insert and then push to release. It's only push to insert, and now you have to physically pull it to release. So they've changed the SD card connector on this. Just a minor thing, but it's worth noting for anybody. So that's it all plugged in now. Let me just give the screen a clean. Well, and I'm not going to plug anything in here except for my keyboard adapter, because I don't know whether I'm going to need it or not, so I'm going to plug it in right away. Because there is Wi-Fi and Bluetooth already on here, I'm not going to bother plugging in for a mouse or for anything else, because I should be able to hopefully use all of the devices that are on board. If not, we will obviously have to make adjustments as we go through the video. So let's just get ready to power this up. So this is the screen. Unfortunately, the Raspberry Pi screen is highly reflective, so it's showing up everything in the background at the moment. I'm hoping that once it comes on, the reflections will disappear. So let's see and give it a go. Just going to plug the power in now. Okay, power's in, and we're booting up theoretically. And of course we've flipped upside down, so let me just turn things over for you. So first thing we notice here, of course, is coming up with a warning saying no network access. I also noticed that the Wi-Fi indicator up here is not lit either for the built-in Wi-Fi. So obviously it's using the touch screen, but the Wi-Fi is not being enabled, which is not too encouraging there. So what I will do right now, for the sake of doing this method, is use the hardwired Ethernet cable, and I'll plug that in and go from there for this particular install. Okay, that's it plugged in. So once we've got this up and running, there's all the apps now showing up. So once we've got the point of Windows 10 IoT running and it goes to do its reboot, I will unplug the hardwired network again to see if it actually recognizes the Wi-Fi right off the bat. I'm a little bit disappointed that Noobs is not recognizing the Wi-Fi, but you know, at least the touch is currently working. So let's pick that one and we'll click, which is the Noobs Windows 10 IoT Core, and we'll click on install. And as you notice, we're doing this all from the LCD display. I'm going to say yes. So it's going to take a little while to download. Now what I'm also going to do while I'm at this is change my keyboard to be the English US keyboard, and my region was already in US. So insider agreement will say yes. Keyboard is plugged in, and set the language. So we'll say OK here. Now I'm going to pick the insider preview because I do have Insider Preview, and I know that that is the one that supports the touchscreen, and the previous current public one does not. And Windows 10 Core Insider Preview. Select the device, which of course is going to be Raspberry Pi. And we'll confirm that. And we'll say download now. And now we wait a little while. So all of this so far has been on the Raspberry Pi Model 3, and it's working fine, except for the fact that the noobs did not recognize the Wi-Fi yet. When this gets to about 98%, I'll resume the video. Okay, we're up to 97%, almost done. It's been about 5 or 6 minutes, I think, while this has been running and downloading, and we'll see what happens. Now, as I said, as soon as this starts to reboot to come up, I will unplug the hardwired Ethernet cable just to see if it will recognize the built-in Wi-Fi. Obviously, if the hardwired Ethernet cable is plugged in, it's not going to prioritize to try and even work on the Wi-Fi. It'll just default to the hardwired one. So if my hand gets in the way a little bit while I do this, I apologize, but I've just got to wait for it to reboot and then I'll unplug it. Okay, so that's successfully done. So I'm going to unplug the Wi-Fi now, the wireless. No, sorry, the hardwired Ethernet, which is done. So I'll move that out of the way. Now we're ready just to simply say OK, and now it's going to reboot from cold. So let's bring up a stopwatch of some sort. I'll do that on my cell phone, and we'll see how long it actually takes to boot. Just getting that ready. Stopwatch. Okay, ready to go. So let's just say OK, and we'll start the timer. There's the Windows logo, 10 seconds. Just done a bit of disk checking, which it hasn't normally done. I haven't never seen it do that before, so I'm surprised that it did that, but never mind. That's probably ruined our boot up time first time. It's up to 47, 48 seconds right now. Minute and 6 seconds. So still the little overlapping text, which is purely cosmetic. And there we have it, 1 minute 27 seconds to boot right up. Now that included a disk check, so we may do I'll do another boot up check later on. Right now though, this same thing as I showed you the other day with the Raspberry Pi 2 is that even though I can select my English United States, I cannot hit enter because it's off the bottom of the screen, and the LCD drivers are not compensating for the fact it's an 800 by 480 screen. So you can't get to the buttons. Once it's actually defaulted through though, everything works and you can slide the screen around, so that will work fine at that point. But for now, we're kind of stuck with waiting for it to time out. And there we go, it's now timed out. So we have OS version 14262.1, and that's exactly the same as before. So now let's see if it actually recognizes the built-in Wi-Fi. So we'll go here, and we'll go Network Wi-Fi, and hit refresh, and currently it is not recognizing the built-in Wi-Fi, which is a little bit of a shame. It is obviously working with the LCD display quite happily, but it is not working with the Wi-Fi adapter. Not at all. So that means that I'll need to plug in, well, right now for the rest of this particular piece, I will plug back in the hardwired network cable. We do know that it's working with the LCD, and the main point of this particular thing is to verify that it's working with the LCD. Now, the one thing obviously wrong here too is it's not recognizing that it's a Raspberry Pi 3. It's still showing it as a Raspberry Pi 2 as well. I'll have to look into that. I'm sure Microsoft is working on some updates, but for now, I just want to verify that it is working. So you can see here the touchscreen is working quite happily. And I actually do have a demonstration application that I can try to upload straight to this, which actually does use a browser. And that was one of the other questions a lot of people have been asking, is about the fact that you can't do browsing with this. There isn't a desktop on here, and there is an Internet Explorer, but there is actually a browser control available within the Visual Studio library that you can use. So I'm just going to finish off this little specific demo with the LCD and Windows 10 for IoT on a Raspberry Pi 3, even though it's not showing you that it's a Raspberry Pi 3. Okay, so I'm just going to show you here is using the built-in web view control on a Visual Studio application for the Raspberry Pi. So it's a universal app, and I have on there a simple URL text box with a button and a browser window. I'm just going to browse to my FLIR AX8 web page, which should show a real-time display of a thermal image, and it should display on the Raspberry Pi. Now it probably will be a little longer than the screen just because of the size of the image that comes from it, but nevertheless it still should work just fine. So let's just run this, and it should upload to the Pi, hopefully. I just had to change the IP address of the project to suit the new Pi. I've never tried running this on a Raspberry Pi 3 yet, so it will be interesting to see if it works without any changes. Theoretically there should be no changes. Still busy compiling and preparing. And here we go. Alright, so what you're seeing here now is a very basic application. It just consists of two grid layout controls and a text box with a button. So this is the IP address of my FLIR AX8 thermal imaging camera, industrial thermal imaging camera. And all I need to do is confirm, and I'm using the touchscreen here, and say view, and it should load the thermal imaging. Now it needs a username and password, so this is where I use the keyboard because there is no virtual keyboard on here yet. Admin, and I haven't changed it from the default, so it should be just admin, and we'll log in. Now this is a standard web page from an industrial camera, so as you can see here, it is actually working just fine. Now the image and the whole page is bigger than what the display is, but you can see it can scroll. We can look down at the alerts and alarms and everything else. We can scroll down and go back to the image, and I can actually, these boxes that are on the image here, I can actually, using the touch screen, I'm able to actually move them around, if you look, quite happily. So that shows you that Windows 10 IoT is working perfectly well on the LCD display. Now this is, as I said, is the version 1.0 of the LCD, not the 1.1. I don't have one of those yet, and it's working very, very well. So I can't speak to the 1.1 display model. This is just the 1.0. This is the insider preview of the Windows 10 for IoT, and this is the latest versions of that using noobs to do the installation. So yes, we've confirmed that it doesn't seem to be using the Wi-Fi at the moment, but it is seeing the LCD no problem at all. So let's quickly go back to the PC and see if it will recognize the Bluetooth adapter at all. Okay, so here is the IoT dashboard for Windows 10 for IoT. And let's just go into the web page, administrator, and p at ssword. So we're in. Just say OK. I don't want to change the passwords yet. Yeah, it's not recognizing the Wi-Fi. Let me just turn on my cell phone Bluetooth and see if it recognizes it. The Microsoft adapter did work in this, but I don't know if the Raspberry Pi one is going to be so lucky. Just going to make it discoverable now. Okay, it's now discoverable. Yeah, still not working with the new Wi-Fi components. So it looks like Microsoft has not updated this to specifically take care of the new Raspberry Pi 3 features at this point in time. Certainly not with this specific image, which is the 14262.1. It does see it here as a Raspberry Pi Model 3, which is nice, even though the display itself says Raspberry Pi 2. And it does confirm, though, that with the 1.0 7-inch LCD display, that the Windows 10 IoT on a Raspberry Pi 3 is working just fine. Now, I know that with Windows 10 IoT on a 1.1 display, there were issues with the public release of the display, but because I don't have a 1.1 display, I can't verify that yet. I'm trying to get a hold of one, but until I do, I can only verify what's happening with the 1.0 version of the display. Anyway, that completes this video. I will be doing some other ones very quickly to show the Raspberry Pi working with some hardware connecting to Arduinos and everything else using Windows 10 IoT. I was hoping to be able to do that with the built-in Wi-Fi and Bluetooth, but we'll have to circle back to those once they get the drivers updated to work with it. So just gone to the Microsoft IoT site on their github.io site and looked at what's new for the Windows IoT Core Insider Preview for the Raspberry Pi 3. And it confirms here that the built-in Wi-Fi and Bluetooth is not yet supported, so you can continue using compatible USB and Wi-Fi Bluetooth dongles, but you will have to wait for a future release of Windows 2 IoT Core Insider Preview. So before I wrap up, I just want to quickly show you from a cold start boot up time for the Windows 10 IoT that's been created using noobs. So let's just power this up right now and see how much time it takes. I've got a stopwatch ready, so let's go now. So that's 10 seconds to the end of the noob splash screen. So we could take that off of the normal boot time if you make this image directly from an ISO. And there we go, 47 seconds from cold to here. So I think my Raspberry Pi 2 boot times were slower than that. So 47.9, so 48 seconds from cold to completely powered up. As I said, you can take 10 seconds off of that because there was the noobs in front of it, which was the precursor to booting. So 47, so 37 seconds would be 38 seconds would be the boot time. I think that the Raspberry Pi 2 was near about 60 seconds. Anyway, that's it. So speak to you soon. See you soon.